So we are now in chapter 5, part C. So in part C, what we are going to do is to learn how to name the compounds. On the previous ones, we learned how to write the formulas. Now, given the formula, can you name the compound? And the first thing I have to mention is that we have what we call the UPAC system, which is the unit of pure and applied chemistry, and this is international. So the international unit of pure and applied chemistry, which is the organism that tells us the rules on how to name compounds. However, a lot of years before that organization was instituted, we were already naming compounds, and some of the names of the compounds are still around that do not follow the system. The classic one, as you saw on your textbook, is water. We all know that water is H2O. Most of you should know that because you've seen it since you were growing up and going to school. The UPAC name for that would be dihydrogen monoxide. So that would be the UPAC way of naming water. However, who uses that? Nobody uses that. So this is what we call a common name. So water would be H2O, NH3, which very soon you will know that we call this ammonia. We do not call it using the UPAC system. So that's the difference between the common names and the systematic names. How are you supposed to know the common names? You're not supposed to. You're just supposed to, if you have been hearing them through your life, then you know them. But there's no need for you to go running to try to find every common name for everything. Just be aware that if you see a chemical name and it doesn't follow what you're going to learn here, it's because it's a common name. That's all you have to be aware of. So the objective then, we're going to be naming ionic compounds. That's all we're doing on this part. Ionic compounds. And we're going to learn how to name them when the metal have only one type of ion, when the metal have more than one type of ion, which is basically transition metals. Remember I told you transition metals are going to be the ones with more than one type of ion. But you also have some exceptions like lead, tin, bismuth, and the other ones I told you on the periodic table. You can check the previous recording. And we're also going to do it with polyatomics. And you have already been introduced to polyatomics. We're going to see now how we go from the formula to the name. So let's begin with this. Name binary ionic compounds containing a metal that forms only one type of ion. So I know that any metal on group number 1, lithium, sodium, potassium, rubidium, and cesium, all of those are going to be 1+. And there's no other choices. Those are only going to be one type of ion. The same with group number 2. Beryllium, magnesium, calcium, strontium, and barium. Those are always going to be 2+, so only one type of ion. So when I say binary ionic compounds, that means that you're going to have 2 elements. Therefore, binary is going to be a compound because they're different. And it's going to be ionic because one of them is going to be a metal and the other one is going to be a non-metal. So we're talking only one type of ion for the metal. So what is the UPAC system we use for this? Remember, this is the institution that tells us the rule, the International Unit of Pure and Applied Chemistry. It tells us that you're going to take the first one and you're going to name it as per the periodic table. So when we look, for example, at K on the periodic table, it says potassium. So you're just gonna name it potassium, as simple as that. So let's take that specific example. So let's do an ionic compound with potassium. Potassium. So I need a non-metal. Let's pick up chlorine. So it's binary because I have two elements. That's what binary means. It's ionic because I have a metal and a non-metal. Just kind of a rehashing what we already said. And it contains a metal that only forms one type of ion, anything on group 1, group 2, or group 3. So how are we going to name this? You're going to take the first one and name it according to the periodic table. Potassium. The second one, according to the periodic table, is chlorine. But if I said potassium chlorine, am I talking about potassium and chlorine? Or I'm talking about the compound potassium chlorine? You don't know. So we're going to fix that by saying, let's not call it chlorine. Let's call it chloride. So seeing the ending IDE at the end indicates that I'm talking about a compound. So that's what UPAC tells us to do. So a compound will end on IDE, except it's a polyatomic. We're going to talk about that very soon. So the name for KC is KCl will be potassium chloride. So the second one, or the anion, this is the cation, this is the anion. The anion is it's modified to IDE at the end. Let's do another one. Let's say I have NGBr2. So I'm asked to give the name of that. So the first one is straight from the periodic table. Magnesium. The second one, which is bromine, is going to be modified to indicate that this is a compound with IDE, bromide. Notice that, for example, having magnesium bromide versus magnesium sodium bromide, the IDE on both of them tells me that I'm talking about compounds. And I want to bring you to your attention that this number, having 2 bromides versus 1 bromide, that is not reflected on the name. There's no need for that. When we start talking about molecular compounds, then that becomes a super important factor. When we're talking about ionic compounds, that number does not show on the name because it's irrelevant. We don't need that. So that's how we do it with one type, with a metal that can only have one type of ion. Basically, it is not a transition metal, and if it happens to be a transition metal, it has to be zinc, cadmium, or silver, which are the only transition metals that only form one type of ion. I have repeated that several times, so that's super important. Another example, we're still doing binary ionic compounds. So binary, 2 elements, one of them is a metal, the other one is a non-metal. So binary and ionic, containing a metal that forms more than one type of ion. So this is a transition metal for the most part. Or it could be lead, it could be bismuth, and all the other ones, the other 4 that I showed you on the periodic table. So how do we do that? Well, let's say that we have these 2 compounds. How do we know which is which? Well, this is what we're going to have to do. We know that this combines with that, give me 0. Remember that? That means that the iron, which is a metal, is positive, I just don't know the number because this can form more than 2 ions. And the chloride, I know from the periodic table that this is -1. But how many do I have? I have 2 of them, and I know that this plus this has to give me 0. So the only thing the iron can be is iron 2 plus. So once more, you have the formula. The charges of the elements combined in any compound have to give you 0. You have 1 atom of iron and 2 atoms of chloride. You know that chloride is -1 from the periodic table. So the iron will have to be 2 plus to give you 0. 2 plus plus 2 negatives is 0. So that tells us that this iron that we're dealing with here is iron 2. That's the important thing to do. On the same logic, these two combined are going to give me 0. The iron is a metal, so I know it's positive. I just don't know how much. And the chloride, I know from the periodic table that it has to be -1. But there's 3 of them. So this plus this has to be 0. So the only choice is that the iron is 3 plus. So that just told me that the iron is 3 plus. That's the important part. So I'm dealing with iron 2 plus on the left, and I'm dealing with iron 3 plus on the right. So whenever you have a metal that has more than 1 iron, you have to specify in the name which one we're dealing with. So like before, according to the UPAC system, I'm going to take the first one, and I'm just going to say, according to the periodic table, this is iron. I'm going to take the second one, and which is chlorine, but because this is a compound, I'm going to modify it to chloride. And then how do I tell you that this is iron 2? I'm going to use a Roman numeral. So whenever you have a binary ionic compound that have a metal with more than one type of ion, because it's a transition metal, you have to tell the charge of the metal with a Roman numeral. So that means the other one, the one on the right, is going to be called iron, Roman numeral 3, chloride. So it's 3 plus, Roman numeral 3. So if you need a review on Roman numerals, that would be 1, that would be 2, that would be 3, that will be 4, that will be 5, and in chemistry, it's rarely that you will have to go over 5. Most likely, you're going to be using the first 4 only. So let's go to the next way of doing ionic compounds. So now, we're still doing ionic, which means I'm going to have a metal combined with a non-metal. Notice that this one doesn't say binary. So we're not dealing with binary anymore. We're going to be dealing with more than 2. So we're dealing with poly, a lot more than 1, polyatomic ion. And what are the polyatomic ions? Well, remember that we learned that? The polyatomic ions are going to be, for example, ammonium, nitrate, phosphate, hydroxide, cyanide, acetate, and all those. Those are in the table. You don't have to memorize them. I know them from memory because I use them a lot. The more you use it in Alex, the faster you will work on the test because you don't have to memorize them. So how are we going to do this? This is super easy. Let's say, for example, that I have KOH. You have to recognize that this is one of the polyatomic ions and its name is hydroxide, and that's on the table. And like always, the first one according to the periodic table. And just like that, the name of both of them. You don't have to modify anything. This one, the name is already modified with IDE. If I have, for example, something like this, from the periodic table, sodium, from the polyatomic ion, phosphate. So just put the name according to the table. And remember, if you're dealing with not that one, that wouldn't be a good example. If you're dealing with something like this, let's say, if you're dealing with something like that, immediately you say, oh, that's platinum. That's a transition metal. So the only thing I know for sure is that it's a metal, so it's going to be positive, but I do not know what number. And I'm going to need the number to find my Roman numeral. However, I know that I have two of these, right? So I have two of those. And according to the table, this is always -1. So this plus this has to give me 0, right? So this is question mark plus 2 negative. So the only thing PT can be is 2 plus, so it gives you 0. So this is going to be platinum, straight from the periodic table. It's a transition metal, so I have to indicate the charge with a Roman numeral. And from the polyatomic ions table, I know that NO3 negative is called nitrate. And that's how I do the name. So make sure you practice that. Go to the tutorial videos, go to the textbook, which it tells you step by step how it's done, or rewatch this recording. So now you're ready for us to do the learning check. So name each ionic compound. In each of these compounds, the metal forms only one type of ion. Only one type of ion, so no need for Roman numerals. So this would be cesium chloride, because it's a compound, right? IDE. Strontium, bromide, potassium, oxide, lithium, fluoride. So they're compounds because all of them end on IDE. So that's easy because there's only one type of ion. What happens when I have more than one type of ion? Well, this is a transition metal, so I'm going to have to find out what is the number for the positive charge. It's a metal, so it's positive. This is also chromium, so I'm going to have to find out the number for the charge. This is tin, which is not a transition metal, but it's one of the 4 I told you to be aware of. So I know it's going to be a more than one charge, so which one it is. And the same story with lead. It's one of the ones that are not transition metal that I told you to be aware of. So if you don't remember what I'm talking about, go back to part B of chapter 5. So I know this is going to be chromium, straight from the periodic table. I know it's a transition metal, so I'm going to have to put a Roman numeral there. And it's going to be chloride. So how do I find out the Roman numeral? I know that this has to give you all combined 0. The chromium, I do not know how much it is, but the chloride from the periodic table I know is negative, and I have 2 of them. So this chromium, for this to be 0, is going to have to be 2 plus. Therefore, Roman numeral 2. Let's do the next one. The next one is going to be chromium also. I'm going to have to put the Roman numeral, and it's also going to be chloride. And if we follow the same logic, chromium, I don't know how much it is. Chloride, I know is negative, but there's 3 of them. So this has to be 3 negatives, all combined. So for this to be true, the chromium will have to be 3 plus. So 1, 2, and 3 plus. Let's do the next one. The next one is going to be tin. This is one of the ones that I know is going to need a Roman numeral, even though it's not a transition metal. The same with lead. It's going to need a Roman numeral, even though it's not a transition metal from the previous recording. And it's with oxygen, so it's going to be not oxygen, but oxide. And this one is with iodine, but it's not going to be iodine, it's going to be iodide. And for the tin, we have SnO2. So the tin is, I don't know how much positive, but the oxygen, which is 2 of them, according to the periodic table, should be -2. So all these combined give you 0. So this will have to be 4 plus. So then we do a 4 Roman numeral in there. And the lead is one of those that I told you we don't know what the lead is going to be, because even though it's not a transition metal, it has more than one. But the iodide, there's 2 of them, and according to the periodic table, on group 17, should be -1. So the only number this could be, to be 0, it's going to have to be 2 plus. So therefore, 2 plus. So make sure you review that if I lost you at any point in there. And the last one is with transition metals. So I know this is going to be barium. I know this is going to be lead. And lead, I already know it's going to need a Roman numeral. This is a polyatomic ion, better known as ammonium. So I'm only doing the first element, or the first cation. This is going to be potassium. And this is going to be cobalt, which I know is a transition metal, so it's going to need a Roman numeral. And then this is a polyatomic ion called nitrate. And that's all I have to do. There's no need for me to worry about this number. So barium nitrate. The next one, according to the periodic table, that's going to be acetate. And I know if I have PbC2H3O2, and I have 2 of them, I know that both of them combined is going to give me 0. The lead is a metal, so I know it's positive. I don't know how much positive. And the acetate, according to the polyatomic ion, is -1, but I have 2 of them. So this is basically question mark plus 2 negative equals 0. So this is going to have to be 2 plus. So the lead is going to be 2 plus acetate. And this is nothing more than iodine, but this is a compound, so iodide. And then this is a polyatomic ion, so I had to have the table available to realize that. And that's going to be chlorate. And then I'm going to have my cobalt with this, which is called sulfate. And I know that the compound is going to be equals to 0. I know that the cobalt is a metal, so it's positive, but I don't know how much. And the sulfate, according to the polyatomic ion table, is 2 negatives. So this is going to be something plus 2 negative equals 0. So this is going to have to be 2 plus. So we basically cover all 3 different rules in one shot on this problem. So I guess now is your turn. So you can do all of those. Apply all the different rules with one, more than one ion, only one ion, and the polyatomics. So with that said, we have covered how to do binary ionic with only one type of ion, binary ionic with more than one type of ion, and no binary polyatomic ions. And that would be a good place to start, because when we come back, we're going to do not ionic compounds anymore. We're going to start doing molecular compounds where the subscript that I told you do not worry on the ionic is going to be extremely important on the molecular compounds. So I see you the next time. Take care.